place. So, in that perspective, a strictly naturalistic explanation like Earth lights, well, if Earth lights are physical, then why do they violate the laws of physics?
Right. Okay.
And Greg, I think as well, when you look at that idea of everything can be explained naturally, we don't live in the future. We live in the here and the now. We have to explain this phenomenon the best way that we can. We don't want to presuppose that everything has a natural explanation without some real good evidence to support that.
Okay, well, let's just summarize what we've discussed so far in our first segment. What we've determined is that while the vast majority of UFOs have a naturalistic explanation, you believe that there's a small percentage, maybe 1 to 5%, which is really a large number, as it turns out, of credible UFO encounters that don't have a natural explanation. And we're calling these residual UFOs, or RUFOs.
Yeah, physical effects, but coming from a non-physical cause.
Okay, so you believe the RUFOs are not only real, but there's evidence to believe they're not actually completely physical because they exhibit these behaviors that violate the laws of physics.
And hence this explains why people are so disturbed by UFOs, because there's a strong philosophical bias in much of modern society which says there is no such thing as non-physical reality. And so all of this evidence is simply rejected. But in the case of UFOs, I think we really do have hard evidence for non-physical reality, and there's hard evidence for that in other disciplines of science. Astrophysics gives us hard evidence of non-physical reality. So I think we can use that to help people get over their natural bias against such explanations.
Well, in the next segment, I want to ask our panel of experts, what are the chances of finding life in outer space? Or are we alone in the universe? Thank you both for joining us, and thank you. See you next time.
While about 95% of all unidentified flying objects are reclassified as identified flying objects, there still remains a 5% residual of sightings that defy conventional explanation. Of the theories to explain residual UFOs, the most popular theory is called the extraterrestrial, or ET, hypothesis. Are humans really alone in the universe? Do these residual UFOs carry visitors from other worlds? Can we really know if intelligent life exists elsewhere in the universe? Stay with us as we visit extraterrestrials as the basis for the rUFO hypothesis.
Welcome once again to this special edition of Reasons to Believe. Now, we've been discussing the rUFO hypothesis. Our panel of experts have been developing a theory that best fits the facts surrounding UFOs and also offers a unique approach to this very difficult problem. I'm your host, Greg Koukl, and I'm joined today by astronomer and minister and UFO researcher, Dr. Hugh Ross. Welcome back, Dr. Ross.
Thank you.
And joining Dr. Ross is cult researcher, Christian theologian, and philosopher, Mr. Kenneth Samples. Ken, welcome back.
Hello, Greg.
Now, both of you are co-authors with Dr. Mark Clark of the book Lights in the Sky and Little Green Men, a Rational Christian Look at UFOs and Extraterrestrials. It's published by NAV Press, and some of our viewers might want to get a hold of that book if they want more information about what we're discussing here today. Now, gentlemen, we began last time discussing the idea that the vast majority of UFO sightings have explanations, natural explanations, aircraft, planet Venus, that kind of thing. But there still remains a number, 1 to 5% of the sightings, which actually is a fairly large number, as you characterized it, Dr. Ross, that don't have an explanation yet. These are the rUFOs, or residual UFOs, that we talked about. Now, we briefly began to look at 3 possible explanations for those residual UFOs, and we talked about theory number 1, which is naturalistic explanations, and we realized that there are some good reasons not to lump all those residuals as having naturalistic causes that we don't know anything about yet. Right. That's really hoping in the future, and that's not a safe way to go scientifically. It doesn't comport with the evidence as you've described it. I want to look now at theory number 2. This is the extraterrestrial hypothesis, the ET hypothesis. This brings to mind Dr. Carl Sagan, a universe that's teeming with life. Now, Hugh, you're an astrophysicist. That's your field. Is it plausible that we live in a universe that is filled with life, as Dr. Sagan suggested?
I would say no, for 2 reasons. One is the failure of a naturalistic explanation for the origin of life in any environment in the universe, even in its simplest form. And number 2, the anthropic principle. And you mentioned Carl Sagan. He's the one that first popularized the idea that our solar system must be fine-tuned, that certain characteristics must be narrowly defined for physical life to be possible on our planet. Then Robert Dicke from Princeton University, a physicist there, was the one who first introduced the idea that the universe likewise must have narrowly defined characteristics for physical life to be possible. And Carl never really kept up to date with the advance of these narrowly defined characteristics. He was the one that made the point that you have to have a certain kind of star for life to be possible. And the planet that has life on it must be a certain distance from that star for life to be possible.
This would be an example of one of those fine-tuned factors that you're talking about, right?
So that gives you 2 fine-tuned characteristics, and based on those 2, he says, well, given that there's so many stars and planets in the observable universe, that would add up to thousands or maybe even tens of thousands of possible life sites in our universe, even in our galaxy. But the problem is that we know of many more than just 2 characteristics of the solar system that must be narrowly defined to make any kind of physical life possible. In fact, what you'll find in the book that we've co-authored is that there are 147 different characteristics that must be narrowly defined for a planet to be capable of supporting life. For example, the galaxy's got to be just right. Not any old galaxy will do. You need a middle-aged, medium-large size galaxy that's spiral in structure, sustaining star formation for billions of years, far away from any large cluster of galaxies.
Now, so if I understand you right, what you're doing is when you look at all of these galaxies that are theoretically candidates for life, these factors eliminate a bunch of them from the get-go.
99.9% of all galaxies are eliminated right at the get-go.
And that's just with 1 characteristic you're talking about.
Those are 3 characteristics of a galaxy that must be fine-tuned for physical life to be possible.
What are some of the others?
Well, then you start to examine, well, okay, if you have this just right galaxy, which stars in that just right galaxy would be candidates to have planets like Earth? And you discover that the characteristics of the star must be very narrowly fine-tuned. It must be a star of almost identical the mass of our star, the Sun, of the same age as our star, the Sun, the same spectral characteristics of our Sun. It must be a star that's orbiting what's called the co-rotation distance from the center of our galaxy. In other words, it can't be too far from the center of the galaxy. It can't be too close from the center of the galaxy. It must be a star that stays in the plane of the galaxy. It's not allowed to bounce up and down in the plane. And so the bottom line is you're eliminating the vast majority of stars in that just right galaxy. It's much more narrowly defined than the galaxy. Then, of course, there's the planet. The planet must be fine-tuned, and it must have the right planetary companions. Jupiter and Saturn play a critical role in whether or not our planet can sustain life. If they're too big, they'll disturb the orbit of the planet. If they're too small, then Earth would get hit by too many comets and asteroids.
Because the gravitational field of the others protect the Earth in a sense.
Right. And the moon is critical. You have to have just the right moon orbiting this just right Earth.